Milky Way, humanity's final frontier. Can we really find and reach Earth 2.0? In his later years, Stephen Hawking famously warned that humanity was living on borrowed time. According to his estimates, we may have only 1,000 years left before we face existential catastrophe, not from external forces like asteroids or alien invasions, but from dangers of our own making: nuclear warfare, engineered pandemics, environmental collapse, and AI run amok. Yet Hawking didn't leave us in despair. He offered a vision of escape. Humanity must become a multiplanetary species. To survive, we must reach out beyond Earth, settle new worlds, and scatter our existence among the stars. But is this even remotely possible? Could we truly find another Earth? And if so, could we get there? Telescope the elusive second Earth. What makes a planet habitable? Before we can think about traveling to other star systems, we have to ask, what exactly are we looking for? To support life as we know it, a planet must meet several critical criteria. Habitable zone, also known as the Goldilocks zone. This is the orbital distance from a star where temperatures are just right for liquid water to exist. Not too hot, not too cold. Earth-like composition, rocky worlds as opposed to gas giants, with a stable surface. Atmosphere. A protective layer capable of maintaining surface pressure and shielding life from radiation. Magnetic field. To deflect harmful solar winds and cosmic rays. Stable orbit and star. Long-term climate stability is essential for life to evolve. Of nearly 7,000 exoplanets discovered so far, only a small fraction meet even a few of these conditions, and fewer still appear to be promising Earth analogs. Globe showing Europe-Africa top candidates for Earth 2.0. Let's take a closer look at some of the most exciting Earth-like exoplanets known to science. 1. Teegarden B and C. Distance: 12.5 light-years. Star: Teegarden star, a cool red dwarf. Highlights: both planets are very close in size and mass to Earth and are located well within the habitable zone of their dim star. Challenges: their host star is extremely old, 8 billion years, which could be a plus for biological evolution, or a minus if it means the planets have lost their atmospheres over time. In a poetic twist, from Teegarden system, Earth will become visible as a transiting planet in 2044, meaning an intelligent civilization there could soon discover us just as we're hunting them. 2. TOI 700D and E. Distance: 100 light-years. Star: red dwarf, TOI 700. Highlights: TOI 700D has an Earth Similarity Index, ESI, of 0.94, one of the highest recorded. It's roughly Earth-sized and receives about 86% of the stellar energy we get from the Sun. Drawbacks: it's likely tidally locked, meaning one side of the planet always faces the star, potentially causing extreme temperature differences. Models suggest it might either be a dense ocean world with cloud cover or a dry desert world. 3. Proxima Centauri b. Distance: 4.2 light-years, the closest known exoplanet. Star: Proxima Centauri, a flare-prone red dwarf. Highlights: located in the habitable zone, with a minimum mass similar to Earth's. Drawbacks: Proxima Centauri emits violent solar flares that may have stripped Proxima b's atmosphere. Still, there may be a twilight zone between the hot and cold hemispheres where liquid water could exist. Rocket the Great Leap, interstellar travel. Even if we identify a habitable exoplanet, we face an overwhelming obstacle: the sheer distance. For context, 1 light-year equals 9.46 trillion kilometers. Our fastest spacecraft to date, Voyager 1, would take over 70,000 years to reach Proxima Centauri. So, how can we possibly escape this astronomical hurdle? Construction: current space travel limitations. Chemical propulsion: rockets like Falcon 9 or Artemis inadequate for interstellar travel. Ion drives and nuclear propulsion: theoretical options that could improve speeds, but still fall far short of what's needed. Shooting star future concepts under development. 1 breakthrough starshot. Goal: send tiny, gram-scale probes to Proxima Centauri at 20% the speed of light. Method: use a ground-based gigawatt-scale laser array to propel light sails attached to microchips. ETA: a trip would take 20 years. with data taking for more years to reach Earth. 2. Sunbeam, NASA concept. Similar to Starshot, but proposes solar particle beams to power spacecraft during flight, a kind of cosmic gas station. 3. Project Longshot and Icarus. These propose nuclear fusion-powered starships, far larger than Starshot's probes, potentially capable of carrying humans. But such missions would likely take centuries and require generation ships, vessels where entire generations live and die before reaching their destination. DNA, the philosophical catch. Is survival worth it without humanity? Even assuming we master interstellar travel, and even if we find an ideal Earth-like world, Hawking's warning lingers. Will we bring the same problems with us? Overpopulation, environmental abuse, warfare? In many ways, our ability to survive on other planets is as much a moral challenge as a technological one. It's not just about building rockets. It's about ensuring we don't export our self-destructive tendencies to new cosmic frontiers. Telescope the road ahead. Webb, HabEx, LUVOIR, and more. Several future missions are already laying the groundwork. James Webb Space Telescope JWST, currently studying exoplanet atmospheres to detect signs of water, oxygen, methane, and possibly even biosignatures. HabEx and LUVOIR proposed. These next-gen space observatories aim to directly image Earth-like planets and analyze their atmospheres in extraordinary detail. The extremely large telescope YELT on Earth will complement space missions with ground-based power. Thought balloon final thoughts. Salvation or mirage? In the end, the dream of finding Earth 2.0 is no longer pure science fiction, but it remains one of the greatest challenges humanity has ever faced. We are at a crossroads. Stay on Earth, solve our crises, and become true stewards of our world. Or venture into the stars, risking the unknown for the hope of survival and expansion. Stephen Hawking saw the stars as our insurance policy, not a vacation. And perhaps he was right. Whether we reach another Earth or not, the journey itself may redefine what it means to be human.